James Brierton in Charlotte. It is April the 24th, 2019. Good evening and welcome. It is spring break here at the Carolina Weather Group. We were scheduled to be off tonight, enjoying the beautiful weather that we're currently experiencing across the Carolinas. However, following last week's severe weather outbreak, the National Weather Service has been visiting many communities across both North Carolina and South Carolina, conducting what they call storm surveys. The National Weather Service storm investigators go out and study the damage left behind by the storms that we saw across the region. Many of them, unfortunately, left behind quite a lot of damage, some that won't be forgotten in communities for some time to come. Tonight, we begin this special by showing you what those storm investigators found. I'll be joined by other members of our Carolina Weather Group panel in just a moment, but first, let me show you this. The storm survey from the National Weather Service in Columbia that studied the EF1 tornado that struck just after 2 o'clock last Friday east of Orangeburg, South Carolina. With winds of 110 miles an hour, this tornado was on the ground for over 7.5 miles. It tore down buildings and trees and left a path of destruction 400 yards wide. This one in particular sticks out in our minds because we were live on the air as this tornado crossed Interstate 26. We believe we've captured the rain-wrapped tornado crossing the interstate. You won't see the actual tornado itself because, like all of the storms across the region that day, they were rain-wrapped, meaning there was a wall of rain around the actual tornado. But nonetheless, you can see the heavy winds, the heavy rain, and the impact it made as it crossed this very busy section of road. Take a look.
Wind damage reports right here. Wow.
All right, yeah, you can see this. This has got to be 60-mile-per-hour winds moving through.
Yeah, I believe that. This is moving through very quickly. And again, this tornado, if there's a tornado in here, it's going to be rain-wrapped. And it's going, it looks like if there's a circulation, it's crossing I-26 right now.
I've got the radar. Can we double box this? I got the velocities up right now on radar in Orangeburg. Let me get that screen share for you all. This is the velocities. Right here is Interstate 26. So right here is what we are watching. I would assume right in this area is the video that you see the rain really moving in, as well as the circulation rotation being shown here on highway or Interstate 26 in Orangeburg, Jared.
Yeah, that's it looks, and I guess the one good thing is that, and we'll keep on Scotty's. Let's see if we can freeze to Scotty's radar, because I think. Well, let's see here. There's still something. There's still, I mean, looking from Charleston, there's still something there, but there could be depolarization from the radar there. Let me switch to Columbia real quick. Columbia's going to have a better view there. It looks like, and it looks like it. Honestly, it looks like it's already starting to improve. I mean, this is, and again, the thing with these storms today is as quickly as they spin up, as quickly as they get rough, they're going to go away and they're going to calm down. And we do have that, that little spot right here, Scotty, that's correlated, this little lowering of correlation coefficient. Now it looks like it's crossing I-26 and crossing I-26 right now, and is continuing to head northeast. And so
Let's show you now some of the other storms that were surveyed by the National Weather Service out of Columbia. We'll get to some of the other parts of the region coming up. This EF2 tornado with winds of 120 miles an hour on the ground for just less than 3 miles near Camp Bob Cooper. You can see the damage there at the bottom of your screen, destroying several structures and leaving a path 250 yards wide as it traveled its 2.91 miles. Another EF2 tornado, this one near Roseville, South Carolina, just before the 2 o'clock hour. With winds of 115 miles an hour, it impacted communities over a 10.5-mile stretch. Again, leaving behind downed trees, power lines, and damaged structures. This EF1 tornado was short-lived but still very powerful, with winds of 95 miles an hour, snapping trees in half as it traveled its 1/3 mile near Molly's Rock area. May not seem like a long path, but something you would have noticed if this short-lived tornado dropped down in your neighborhood. If you live southwest of Whitmire, then you would have noticed this EF1 tornado on Friday just after the 2 o'clock hour, packing winds of 105 miles an hour. It destroyed a trailer. You can see that picture on the bottom of your screen. You hear us talk about it all the time, that these mobile homes, the manufactured homes, unfortunately cannot withstand 100-mile-per-hour winds from these tornadoes. You can see another picture there on the bottom right of another home that was severely damaged. This storm on the ground for less than 2 miles, but still left quite the footprint, with a path of destruction 200 yards wide. Now, for a look at the storm damage elsewhere across the Carolinas, I'm joined by our panelists, beginning with Evan Fisher.
5 days after tornadoes and severe storms ripped through portions of eastern North Carolina as well as South Carolina, and even a few tornadoes over towards western North Carolina, parts of the area are still recovering. And specifically, I'd like to discuss Raleigh and the storms and the tornadoes that they've confirmed over there. So let's go ahead and hop into some storm reports. The strongest of all of them was an EF2 tornado, touched down in White Cross near Hillsborough. We did extensive coverage on this one during our live stream. Had estimated peak winds of 115 miles an hour with a path length of 12 miles and a maximum width of 600 yards. Luckily, no one was injured or killed in this storm, and I actually have a photo of some damage from trail waters of a roof being ripped off a home as well as extensive tree damage. So this was the strongest of the tornadoes that passed through the area, but certainly not the only one. The second one I'd like to discuss is an EF1 that touched down near Spivey's Corner on Friday with maximum wind speeds of 95 to 105 miles an hour, making that an EF1. Another long path length of 10 miles, but rather skinny, with a maximum width of only 125 yards. After that, we have the Robbins tornado, which was certainly shorter, only 1.6 miles long, but it was nearly a quarter mile wide with max winds of 90 to 100 miles an hour. This one was an EF1, occurred around 3 p.m. I have some photos of this one too. If you come over here, you can see that while it was not as strong as the Hillsborough tornado, it certainly caused extensive tree damage. Some of those trees fell on structures and buildings that will take some serious money to repair. Okay, next we have, we'll scroll down a little ways, and I'll show you the last four. So this one is yet another EF1 that passed through a more populated area than the other ones, with the exception of Hillsborough. This one touched down just southwest of Weldon, North Carolina, and moved roughly 5.1 miles before it crossed over the Roanoke River and began to dissipate. This occurred at 6 p.m. an EF1 with 90 to 95 mile an hour winds. It was rather skinny at only 100 miles wide. Next, we had another EF1, and as you can kind of see, we had only one EF2, and the rest of the tornadoes confirmed by NWS Raleigh were EF1s. This is yet another one. This one had the longest path length of any of the tornadoes that they surveyed on the days following the event, with 12.5 mile long path length, and max winds of 95 to 100 miles an hour. This one also was roughly a quarter mile wide and lasted for 11 minutes. No one was injured or killed in that one either. And I believe we have two more. So this one was near Whitakers, North Carolina, just outside of Whitakers, I should say. Another EF1. This one was on the ground for almost 9 miles, producing intermittent tree and structural damage, but it was quite skinny and only 75 yards wide. So didn't quite have the fortitude of the other tornadoes. That leaves us with one more tornado, and we'll scroll down here to see it. The last one was northwest of Siler City. This one actually was another one that we did extensive tree damage. We did extensive coverage on. It lasted for about 2 miles, about 2 minutes long, because the storm was moving very quickly at roughly 50 to 60 miles an hour. The maximum width of 150 yards, 95 to 105 mile an hour winds. And this one was also produced at roughly 3:30 p.m. on Friday. So that is all of the tornadoes that were issued. Tornado warnings and confirmed surveys that were done by NWS Raleigh.
Despite several tornado warnings in the South Carolina low country, straight-line winds were the main story as a strong squall line raced through the area on Friday afternoon, leaving numerous reports of downed trees and power lines in its wake. The storm was particularly rough in Walterboro, where a Baymont Inn had part of its roof peeled back, a barn collapsed, and a tree fell into a house, amongst many other reports of downed trees and power lines throughout the town. A tornado warning was in effect for Walterboro at the time the storm plowed through, but all of the damage was found to be courtesy of straight-line winds. Now, as the squall line raced northeastward through the low country, it kicked up wind gusts over 60 miles per hour at multiple stations in the Charleston metro area. The Chutes Folly Weather Flow station reached a peak gust of 68 miles per hour. This is a new station in Charleston Harbor, and it's got a really good look at what's happening in the harbor. So that was a very strong gust. The NOAA ship Nancy Foster docked at the Navy base, reached 63 miles per hour, and a 60-mile-an-hour gust was recorded at Waterfront Park in downtown Charleston. But the most impressive was the reading from one anemometer, sighted 80 feet high at the Charleston Pilot Association near Charleston Harbor. It recorded an 81-mile-an-hour wind gust. Downed trees and some power outages were the main story in Charleston, once again all courtesy of straight-line wind damage. When the squall line reached Atlanta in Florence County, it did produce a brief EF0 tornado with maximum estimated winds of 80 miles per hour. This tornado damaged a house, lifted a roof off of an outbuilding and shed, and uprooted several trees as it trekked across Woods Bay Road. Nobody was hurt or killed, thankfully, during the tornado's brief 0.6-mile trek. Straight-line winds remained a factor as the squall line traveled through the PD and Grand Strand. A weather spotter in Darlington measured a 70-mile-per-hour gust on a home weather station, while the weather flow station at Winyah Bay and the North Myrtle Beach surface observation both recorded wind gusts of 58 miles per hour. For the Carolina Weather Group, I'm Jared Smith.
I'm Scotty Powell here in western North Carolina, and we were watching those severe thunderstorms move through the area on Friday, April 19th, 2019. Most of the area was under an enhanced or moderate risk of severe weather, and we watched multiple rounds of thunderstorms move through the area, and some of those storms were quite severe. In fact, we had 3 tornadoes reported in western North Carolina. The first tornado was an EF0, which occurred in the Ashford community of northern McDowell County. That occurred around 10:26 a.m. Estimated winds of 75 miles per hour. The storm was on the ground for a little over 0.6 of a mile. Not a lot of damage from this tornado, mostly trees uprooted and damaged, but we did have a little bit of minor structural damage to the Blue Ridge Parkway Inn, which is a little inn up on the Little Switzerland community. It sustained some damage to shingles, some minor damage to some of the siding, and some outbuildings as well saw damage from that tornado. A little later on in the afternoon, around 5:29, a little later on in the afternoon, around 3:29, an EF0 tornado was recorded in Gaston and Lincoln counties in western North Carolina. Again, an EF0 tornado on the lower end of the scale with maximum sustained winds at 76 miles per hour. The tornado, though, was on the ground for a little over 7 miles. It started in the very far northern portions of Gaston County and moved through Lincoln County. In fact, it moved through downtown Lincolnton. Numerous trees knocked down from this storm. In fact, there was one injury from this storm where a tree fell on a home in Gaston County, injuring a person. But normally with these weak systems, you don't see a lot of structural damage, and that was the case with this tornado. And finally, around 4:10 p.m. on Friday, an EF1 tornado touched down in Alexander County in western North Carolina. This was the strongest of the 3 tornadoes recorded in western North Carolina. Maximum sustained winds of 90 miles per hour. We saw a path of about a half a mile with this tornado, and it did create some damage in the community just north of Hiddenite. It peeled away some metal roofing on a barn and tossed the metal piecings of the roofing into a forest nearby. We also saw some shingle and siding damage to a home, as well as numerous trees downed in the area. The Roanoke forecast area in northwestern North Carolina, including some of the Piedmont areas, also saw some tornado warnings, but there was no confirmed tornadoes in that area. In western North Carolina, I'm Scotty Powell for the Carolina Weather Group.
And our thoughts and prayers go out to everyone across the Carolinas recovering after last Friday's storm. Last Friday was just another day here in the spring severe weather season across the Carolinas, one that continues on. If you're not already, we would encourage you to like, subscribe, or follow the Carolina Weather Group on our live platforms, Facebook Live, YouTube, Periscope, and now Twitch, so that when we go on the air with live severe weather coverage, you can get a notification straight on your computer, phone, or other device to let you know that we've entered severe weather coverage. Now, with that, we would like to turn our attention to an upcoming event here in the Charlotte area. It's happening on May the 9th, and you can get information about this, by the way, by going to weather.gov/GSP. That's weather.gov/GSP. It's the homepage for the Greenville-Spartanburg office for the National Weather Service, which actually covers the Charlotte area. They're bringing 2 Hurricane Hunter aircraft to the Charlotte area, and you as a member of the public have an opportunity to go check this out. Again, it's happening on Thursday, May 9th at the Charlotte Douglas International Airport from 2 until 5 o'clock. Information on weather.gov/GSP, but you can go inside these planes, which if you're not familiar with, actually fly into hurricanes to get priceless data. Yes, we have satellites. Yes, we have radar. But when these storms are out over water, the only way to know their true strength is to actually fly a plane with human beings aboard straight into the eye of the storm. And you can check out these planes coming up in May in Charlotte. We had an opportunity here in the Carolina Weather Group in December to talk with one of the meteorologists who flies aboard one of these aircraft. Her name is Heather Halbach. And we want to show you now the interview she conducted with us in December talking about that very busy, active hurricane season we had just wrapped up for fall. You'll remember it included Hurricane Florence, Hurricane Michael, and others. And Heather shares her story with us.
I do want to bring in our guest, Dr. Heather Hallenbach from the NOAA Hurricane Research Division. Heather, welcome to the show. Thanks for joining us.
Thanks for having me.
You're welcome. So you're a new first-time guest with us. So we have that kind of standard first-time guest question. We want to know, how did you catch this weather bug? How did you get caught up into this crazy profession that we're all so involved in?
Well, like a lot of meteorologists, it started at a young age. I grew up in Wisconsin, and we had a lot of severe weather. And I was always very terrified anytime the tornado sirens would go off or we had a severe thunderstorm warning. So I started watching the Weather Channel, and I started learning about the weather. And as I did that, I started to overcome my fears a little bit. And then I discovered hurricanes. You know, being in Wisconsin, you don't really hear about hurricanes too much. But I really remember the 2004 and 2005 hurricane seasons quite vividly from watching the Weather Channel. And I learned that you could fly into hurricanes. I had a interest in planes ever since I was young. My dad was a pilot. I grew up around aircraft and flying in small aircraft. And I love roller coasters and thrill rides. So it was kind of just a natural fit for me. And I made it happen.
So Heather and I have been friends for a long time, and I actually met Heather at Florida State University after she had left the Wisconsin winters and came down to chase that dream of being a tropical meteorologist. And you had some really unique opportunities and internships that took place during your early part of your career. I know that you did some research at the Naval Research Laboratory for a little bit of time, and then you also did some internships with the Hurricane Research Division before you actually got your job there. Can you tell us a little bit about those opportunities that you had?
Yeah, of course. So when I was working on my master's degree, I was in contact with a scientist at the Naval Research Lab in Monterey with their Tropical Cyclone Division. And he informed me about a program that the Navy has for undergrad or for graduate student internships. And so I was able to do that for one summer. I went out to Monterey, California, and I worked with their data assimilation group and working with trying to get data from the Hurricane Hunter aircraft into one of their models. So that was kind of my first experience with the Hurricane Hunter data. And then once I finished my master's degree, I had a scientist from the Hurricane Research Division on my committee for my master's degree. And he said he knew that I was interested in possibly working with the Hurricane Research Division. And he asked me if I'm interested in flying. And I was like, well, of course I am. And so he got me in contact with one of the other scientists at the Hurricane Research Division. And so throughout my PhD, I was working very closely with them, and I spent a few months for a couple years early on in my PhD work down here in Miami. And after that, once I finished my PhD, I got a postdoc with them and moved down here.
So, I mean, you've had just an interesting career just from the internships through your PhD to where you are right now. And I know you have a background in the aviation, especially with your dad and being around airplanes and everything. But I think what's really interesting is being, you know, that's your background. And like you said, you're a little bit of a thrill seeker. This was a natural fit. But it's more than just getting on a plane and just flying into a hurricane. There's a lot of prep that goes into that. And even as a scientist, you have to be prepared to you know, or help with the preparations of the plane. What are the typical procedures that you have to do even before you actually start your job when you get in the plane?
Oh, yes. There's definitely lots of prep that goes into it. So each spring, we actually put together our experiment plan for the season. It's called the Hurricane.
Completed for Category 5.
And
this image hasn't really changed much. It's a little old. It hasn't changed much over the last several hours. Strong storm. Intensified sunny since NOAA Port 2 left.
Answering research questions. So that's kind of the start of our preparation and trying to figure out what types of flight patterns we might want to fly in a certain type of storm that we have the opportunity to sample. But after that, we then go through training. One of the things that we have to do every 5 years, which I have to redo this next spring, is water survival training. This is a 2-day thing where we get together and we have a course, classroom portion of it, where we learn about, you know, what to do in the case we have to ditch the aircraft in the ocean, how to survive if that were to happen. And then we spend a day in the pool learning how to inflate life vests, jump in the pool like you would if you were getting out of the aircraft, learn how to get into a life raft, how to help other people into the life raft. And also one of the important things is we get turned upside down in a cage and we have to get out of a harness and surface. So that's one of the more intense parts of our training. And hopefully we never have to use it.
Now, Heather, are they blowing fans at you at 100 miles an hour too?
No, they're not. Yeah. So yeah, like I said, hopefully we never have to use that. I certainly don't want to.
No, I don't blame you on that. I wouldn't want to do that either. So, I mean, beyond doing the training, are there other types of flight responsibilities that you have to do before you take off?
So before each flight, we start off with a pre-flight briefing from the flight director, who is the flight meteorologist for the plane. And they're an employee of the Aircraft Operations Center. They work full-time with the aircraft. We are the research scientists that then communicate with them, and the flight director then communicates to the pilots and the rest of the crew. So he or she gives a briefing about 2 hours before our flight, where we discuss the current state of the storm, the weather that we might encounter en route to the storm, what our science goals are for the mission, what type of flight pattern we're going to be flying, what type of expendables we're going to be dropping from the aircraft, and what other hazards we might encounter along the way. After that, we meet on the plane about an hour before takeoff, and the aircraft commander gives another briefing about the aircraft safety, the procedures that we would follow if something were to happen while we were on the ground versus in the air, and then recaps the science mission and any other details that might be pertinent to that particular flight. And then after that, we all take our seats and get on our way.
That's pretty awesome. Hey, Heather, I want to jump in here real quick, Melissa. Just kind of curious. I know you guys are flying into the eyeballs of hurricanes. What's the biggest limiting factor with weather with your missions? Is it just time and you know, actually having to travel out to, you know, to where the hurricane may be, because weather isn't that big of a concern when you're flying into the eye of a hurricane.
So yeah, I mean, where the storm is located definitely dictates how long of a mission we can fly, how many, what type of science we might be able to achieve during the flight. But we also can sometimes encounter turbulence that is too strong. And if that's the case, we have to decide whether or not it's safe to continue the flight. It doesn't happen very often, but it has happened where we've exceeded the G-force limit on the aircraft. And so just for safety reasons, we usually will just return to base, and they have to do a full inspection of the plane after that.
And so, Heather, you're talking about flying into these hurricanes. A couple of storms that we wanted to talk about tonight. The first one I want to hit on is Hurricane Lane, and actually, you was part of a history-making flight into Hurricane Lane. It was an all-female flight crew going in and flying into Hurricane Lane and getting all kinds of valuable data. So talk to us a little bit about Hurricane Lane and what that meant to you all being the first all-female crew.
Yeah, so Hurricane Lane was a pretty historic set of missions for us at the Hurricane Research Division. It was actually the first time that we had gone out to Hawaii to fly hurricane missions into, for the Central Pacific Hurricane Center. The plane had been out in Hawaii to fly winter storms before, but we had never gone out there to fly a hurricane mission. So that was the first historic part for us. But then our last mission, it was just kind of fortuitous that it worked out that we had our first all-female science crew, which was pretty amazing to get to share with my fellow colleagues. They've been flying into hurricanes for, over 40, 50 years. And for this to finally happen was awesome. Over the last several years, we've added a lot more female scientists to our division. And as most of you know, meteorology and sciences are predominantly male. And so for this to finally happen was really awesome. And we all had a great time. And it was a wonderful mission. It was Category 5 for a lot of us. It was our first flight into a Category 5 storm. It was my first. So it was a really, really great experience.
And so Hurricane Lane was a big storm. One maybe folks around here may know a little bit more about is you flew into Hurricane Irma, and that Irma was a strong hurricane back in the 2017 season that hit South Florida and portions of Cuba. So talk to us a little bit about flying into Hurricane Irma and your memories from that mission.
Irma was a very different set of missions for us. Being that we're based out of Miami, we were under threat from Hurricane Irma. So we were being hunted by the hurricane rather than us hunting the hurricane for once. And so a lot of us were busy preparing our own homes and making sure our families were safe, our pets were safe, and all of that. And so we had started flying Irma while it was out west or east of the Caribbean. And when I flew it was when it was just north of Cuba and south of the Bahamas. So it was, I believe, September 8th, so 2 days before it made landfall in the Florida Keys. So what happened for me was I stopped in Lakeland halfway along my evacuation route to Tallahassee. I had both of my cats with me. They were in the hotel room. And, we were prepared to stay in Lakeland if we needed to ride out the storm. But my second mission actually ended up getting canceled because the storm was over Cuba and we couldn't fly. So I ended up being able to make it all the way to Tallahassee before Irma made landfall. But that was a really stressful set of missions for us because we were worried about and get that information out to the public in the Hurricane Center.
You brought up a great point about Irma and one of your missions being canceled. And this is something the general public may not know about. So I was kind of going to ask this question. Why is it important that you guys can't fly missions once the storm is over land? Talk to us a little bit about why you guys can't do that.
So it really depends on where the storm is located. So we have a lot stricter guidelines about where we can fly around Cuba. We have to, unless we have clearance from them, which we don't always have, most of the time we don't have, we have to stay a certain distance away from Cuba. So if we can't get through the center of the storm, there's not much value that we can add to the data that's already available. So it's kind of a cost-benefit type of decision in some ways. But the main restriction is that we want to be able to get through the eye of the hurricane in order to be able to collect that data on the center of the storm, the strength of the storm, try and help figure out where the storm is moving by getting through the center.
And so one more storm that's a little bit more recent, and we'll kind of combine the Carolinas here, North and South Carolina. Hurricane Florence had a big impact on both Carolinas. So I know you was able to fly some missions into Florence. So talk to us a little bit about your recent memory of that, because it was only a few months ago.
Yeah, so I was given the opportunity to go out for a set of research missions into Florence. We went out to Bermuda, and we were the first aircraft into Florence. We started flying Florence right after it had already been a Category 4 hurricane and weakened. It was a tropical storm for our first flight, and then we caught its rapid re-intensification all the way up to a Category 4 once again. This was a great data set that we were able to collect for research purposes, but we were also able to get that information into the forecast models, to the National Hurricane Center, so that the preparations could be made further in advance and the models could provide better forecasts since it was not entirely clear what the threat to the U.S. was going to be at that point. And the data that we were able to collect in those missions was able to help clarify that situation. And so it was really great, the timing that we were able to get out there. And then the Air Force was able to pick up those missions once we were reassigned to go and fly Isaac in the Caribbean.
And that's a great segue into what was going to be my next question, was rapid intensification. Have you flown a mission into a situation where the storm is intensifying rapidly? We talk about sea surface temperatures being a major contributor to that, but you're up there in the plane. Do you notice anything atmospherically that's contributing to RI during these storms, especially with Florence, where it was a little higher in latitude? You wouldn't have thought that would have happened. What did you see?
Yeah, we were all quite surprised to see it intensify that quickly. I think that was Lane. We saw really high temperatures in the eye, but I know, so one of the things that kind of keys us into if a storm is intensifying is when we see lightning in the storm, and it's a lot more turbulent while we're flying through it. The other thing that we were able to notice with Florence, with the data that we were collecting, was that the wind shear seemed to be dropping off a lot sooner than what the models were indicating and what some of the satellite analyses were showing. And so with the data we were collecting, we were able to see that, especially with one of the instruments on our aircraft called the tail Doppler radar, which gives us a 3D picture of the storm and different levels of wind. And so I think that was one of the keys for Florence's re-intensification.
Very interesting. And what you just said last about being able to read the winds leads into my next question. So you're an expert. I read your dissertation or some of it. I mean, I wasn't able to peruse through all of it. Very, very nicely done, by the way. But you talked a lot about surface winds and friction, ocean waves, all of these things. And so you use what's called a step frequency microwave radiometer. So talk a little bit about that instrumentation that you're using, how that's gauging wind speeds, and how that ties in with what the aircraft is relaying back to the NHC.
Yeah, so the step frequency microwave radiometer, or the SFMR for short, is an instrument that's on both the Air Force hurricane reconnaissance aircraft and the NOAA aircraft. It's measuring the surface wind speed along the flight track. And the way it works is that the SFMR is measuring the temperature of the atmosphere at microwave wavelengths of the scene below the aircraft. And there's many things that contribute to that, including the temperature of the ocean surface, the rain and other radiation in between the aircraft and the surface. But one of the key factors is that it responds to the change in temperature of the ocean surface that's related to wind speed. And the way that works is that as the wind blows along the ocean surface, it generates waves. And as these waves grow, as the wind speed increases, they break and create white water on the surface. And as the wind speed increases, you get more white water on the surface, which is emitting at a warmer temperature. And so the SFMR is measuring that. And when we remove the other factors, like the base ocean temperature and anything from in between the aircraft and the surface, we can then retrieve the wind speed that's related to that temperature.
Shay, you're on mute, buddy.
Oh, sorry, Scotty. Thank you. Thanks for that. I was going to ask, with the waves horsing rather than white capping as they get bigger and bigger, I think the term is horsing for that. Giant rolling waves, how does that measure to what your accuracy obviously is better than what the buoy readings? A lot of people look at the ocean buoys and they say, oh, the wind speeds are this, but so talk a little, maybe add on to that with what the surface friction does to buoy readings.
Yeah, so one of the things that factors into the accuracy of buoys is that in these really strong storms, you get really tall waves that are most of the time taller than the buoys themselves. And so one of the things that happens is you get wave sheltering for buoys. So if you have a wave where the peak is here, the trough is here, and the buoy's down in the trough, then the wave is completely blocking the wind that's flowing above the ocean surface. And vice versa, when the buoy can be at the top of the wave, and then you might get a wind speed measurement from that, but it's continually moving. And so this wave sheltering plays a big role in how the buoys are able to get wind measurements.
And I'm going to hand this off to Chris now for his question.
Yeah, absolutely. So, they've been talking a lot, Heather, about, some of the weather models and the sensors you guys have on board your aircraft. And I'm really curious about the personal side of it and also the aviation side of it. So I'm going to hit you with a few questions here, nothing too bad. But, you said you grew up in Wisconsin, Oshkosh, grew up loving aviation. What was your mental mindset going into your first IWOL mission once you came on board with NOAA?
So, the first emotion was, very excited. I'd worked a long time to get to that point. But of course, there were some nerves, the unknown, not sure entirely what to expect. But overall, I was just really excited that I was able to contribute to collecting this really important data. And that feeling of knowing that what you're doing is having an immediate impact on people preparing for a storm is a really great feeling.
Oh, that's awesome. And, I see on the Weather Channel a lot, they talk about the different types of aircraft that are out and flying the missions. And of course, the Air Force has the WC-130s, and you guys have the older P-3s, but you also have the Gulfstream. Tell us a little bit about what the Gulfstream does, because I don't think it gets a lot of the notoriety like the P-3s do flying the IWOL missions.
No, it doesn't. No, the Gulfstream 4 or G4, whose nickname is Gonzo, is a very unique aircraft that we have access to. This is a high altitude jet. It flies up around 40,000 feet. It flies above and around the hurricane rather than through it. And it is able to drop dropsons. It also has a tail Doppler radar on board, But the dropsondes that it's able to release are able to collect data in the upper portion of the atmosphere that has proven to be incredibly helpful information for the forecast models. It also can fly a lot further and a lot longer than the P3 can. And so the National Hurricane Center uses it to sample the environment out in front of the storm, which can really help the models identify what's going on out in front of it better and then improve the track forecast for it, along with then also having an impact on the forecast intensity.
Oh, that's awesome. So, basically saying the Gulf Stream is going to give you like the synoptic picture, if you will, for some of our weather weenies out there. That big synoptic picture, both upstream and downstream surrounding the hurricane. And once you get that data and it's assimilated, what numerical model prediction does it go into? You hear so much in the media about, the Euro, the NAM, the GFS, the data that you guys are doing, what's it, where does it show up?
So our main purpose is to gather data for the U.S. weather models, primarily the Hurricane Weather Research Forecast Model, HWRF. But this data goes out to the entire world. So you have it going into a lot of the U.S. models, the European, ECMWF, UK Met models, and many other models.
Oh, that's really cool. And, just curious, as technology continues to advance, with the United States military using drones now in a lot of operations, especially like the surveillance world, is that something NOAA may pursue in the future? Something like a Global Hawk or something like that? I'm sure that's a money thing.
I actually use the Global Hawk. Over the past 5 or 10 years, there's been a few field campaigns that have used the NASA Global Hawk. And that has proven to be incredibly useful, since you can actually fly that all the way out to Africa, just off the coast of Africa, and sample these easterly waves as they're coming off the coast and get a much better idea of what's going on out there. And then, that data gets into the models. They release dropsondes from those as well. They've got other remote sensing instruments on it. And it's been a very, very useful tool. And there's still some talks on to what the future is of that, but they are doing that. The other unmanned aircraft that we've been using is called a Coyote. This is a small UAS that we released through the dropsonde chute on the P3. And we've flown it into the eye wall of a hurricane. The main ones we've done this in were Hurricane Maria last year, and then this year we actually released one into Hurricane Michael. And this aircraft is not a whole lot bigger than, it's probably about 3 to 4 feet long. And it fits in the dropsonde tube, and you can fly it at very low altitudes to collect data in the eye wall. And it's proven to be very useful. And that we are definitely continuing to do. And hopefully we will have them in every storm next year. That's the goal.
Wow, that'd be incredible. I'm sure that would really help out a lot, especially, as storms get closer and closer to the United States. Want to jump into one more thing, and I'll kick it back over to Scotty here. But March 19th, I was in Alabama chasing tornadoes. Caught a little EF1 outside of Russellville. Happened to look up and might have heard P3 and noticed it was NOAA. You guys were flying to P3 around severe storms. Tell us a little bit about that, maybe?
Yeah, so the P3 doesn't just fly hurricanes. During the winter, it's used in all sorts of experiments. Last year, and I think this coming January again, they're going to Ireland to fly winter storms over the northern Atlantic. The past couple years, they've flown for Vortex Southeast, where they fly right around the thunderstorms and supercells, and apparently those are very bumpy flights. The P3's flown all over the world for various different experiments.
That's really incredible. I'm sure it's bumpy riding into P3 at low level around, such a massive updraft of a supercell, 120 mile an hour updraft. I can only imagine what kind of wind shear and turbulence it is, at flight altitude. But that's some awesome information. If you had some advice for anyone that was, interested in aviation or weather, what would you tell them the route to go to get where you are one day?
I would just say to, keep pursuing whatever dreams you have. If you meet somebody that you think has an interesting job or might be able to help you out, don't be afraid to speak up and ask them. It really is about who you know. I was very fortunate. I was very shy, but I met the right people and was able to find my way. But just don't give up. If you really want it, you'll find out how to get there.
That's great advice. And with that, I'll kick it back over to Scotty, I believe.
Thanks, Chris. I was going to ask about flying into winter storms and any advice you may have for folks who are interested in this. But since you just answered those both questions, I'm going to go to question number 3 before we kind of wrap up. Inquiring Minds wants to know, when you guys aren't in the heart of hurricane season and there's not always winter storms to be flying into, what do you guys do in the, per se, off season?
The off season is when we get our research done. So all of that data that we collected, we use in our research. And so we'll go back through all the data and identify which cases might be useful for us in our various different research projects. And we write papers, we present at conferences, and then we prepare for the next hurricane season.
And so, kind of going off of that, looking forward to next year, that you saying preparing for the next hurricane season, what all does that entail? I mean, do you guys, are you basically kind of teaming up, this is how many missions you may get to fly, or what does that look like preparing for the next hurricane season? The past 2 years, it was pretty busy, and then it was, before that was kind of quiet. So how are you guys gearing up for next season? And early indications, do you think you'll be just as busy as you have been over the past 2 years?
So that's the thing, is we never know what the season's going to bring. So we try and, like I said earlier, write up our experiments to cover a huge variety of storms that we may encounter, and just hope that we get some storms that are within range. We would prefer storms that don't impact land but are within range for our aircraft. But it's really just making sure that we're ready to act when a storm happens.
That's some great information. Well, Heather, if our followers who are watching tonight, or maybe some folks who are listening on the podcast, if they want to learn more about the research that you're doing, is there any websites, maybe social media accounts that you would recommend for our followers to maybe follow or maybe get more information?
Yeah, of course. So the Hurricane Research Division does have a website with all of our data that we collect is available on there, along with information about the type of research that we are pursuing and details about all of the different people that work at the lab, along with other things. So if you just Google the Hurricane Research Division, you should be able to find that website. But we also have social media accounts on both Facebook and Twitter, where our Twitter account is most active during the hurricane season. When we're out flying, we like to try and post as many pictures and videos and information about the storm as we can to keep people informed. And you can also get some information from the official NOAA Hurricane Hunter webpage, which is run by the Aircraft Operations Center, and who are the people that maintain and operate the aircraft.
Yeah, and you guys follow that Twitter account, because when they are flying into these hurricanes, it's where you see some of the cool stadium-style photos and penetrating through the eye wall, some great pictures and videos that you all are able to produce in that. So, Heather, we appreciate your time tonight.
We appreciate you checking out that memory from the Carolina Weather Group archive. Again, Heather Halbach, a meteorologist and hurricane hunter for NOAA, recounting her times aboard the Hurricane Hunter aircraft, flying through such storms as Hurricane Florence and Michael. If you want to learn more about what the Hurricane Hunters do, you'll have an opportunity to do that on Thursday, May 9th, right here in Charlotte. You can come down to the Charlotte Douglas International Airport between 2 and 5 o'clock to actually go aboard 2 of the aircraft that fly into the hurricanes to get us all of that priceless data. It's going to be a great time. Again, that's from 2 to 5, Charlotte Douglas International Airport. And leave yourself a little extra time to get through parking, and I think there's a little security you got to go through as well, too. So if you're planning to be there right at 2 o'clock, you're going to want to get there probably a hair early. There's more information about the Hurricane Hunter tour stop here in Charlotte on the website of the National Weather Service Greenville-Spartanburg. That's weather.gov/GSP. Weather.gov/GSP. You'll see a link for the upcoming tour stop of the Hurricane Hunters right here in Charlotte on Thursday, May the 9th. Come say hi to us, by the way. We're going to be out there at the airport, and we'd love to see you as well, too. That does it for this episode of the Carolina Weather Group. I'm James Brierton. We hope if you're on spring break, you're having a lovely time enjoying the beautiful weather across the Carolinas. Cross our fingers. There's no severe weather in the forecast outlook, and we hope it stays that way so we can continue to enjoy this beautiful spring weather. Until next time, I'm James Brierton. On behalf of the entire panelists, we hope you have a great week, and we'll see you back Wednesday night, 8:15 p.m. Eastern Time, for another live episode of the Carolina Weather Group.